Alright, we're going to deal with the properties of exponents, and I'm just going to review them and review the why, because sometimes we forget, but I'm going to mostly assume that you've seen them before. So x squared times x cubed. So x squared is like x times x, and x cubed is like x times x times x, and so if we multiply them together, it's kind of like x to the fifth power. So anytime you have the same base, we can add the powers. So x to the 2 plus 3. So we add the powers. Now this is a power of a power, power to a power, so that's like y squared times y squared times y squared. So that's y times y times y times y times y times y, so that's like y to the 6th power. And so if you have y squared cubed, that's where you multiply. This is the most commonly mixed up ones between these two. Do we add or do we multiply? So if you ever are confused, write it out longhand. So power of a product, so this is 4xy squared, so 4xy times 4xy. So now there are 4 and 4, so that's like 4 squared, and x times x is x squared, and y times y is y squared. We're just grouping like ones together. And so the 4xy squared, I can distribute this power on through. And that's only because I can do it over multiplication. Don't be confused with x plus 2 squared. That does not equal x squared plus 2 squared. Instead, you should do x plus 2 times x plus 2, and so on. So, quotient of the powers, related to this one, except if we have 5 x's on top and 3 x's on the bottom, x divided by x is 1, and so we can cross out 3 of those because those make 1, and so we get x squared. Or in other words, if you have x to the 5th divided by x to the 3rd, like this one up here where we add, we're just going to subtract. So if you subtract and you have 2 b's on top and 7 b's on the bottom. 1, 2, 3, 4, 5, 6, 7. So 2 of the b's cross out and you're left with 1 over b to the 5th. So this is still the same thing. B squared over b to the 7th is b to the 2 minus 7, which is b to the negative 5th. And so this is the negative power property, is where you take 1 over b and raise it to the positive 5th. So any negative power you bring to the bottom and make it positive. And anytime you get it on the bottom, you can bring it to the top. This is very important. This is probably one that you might be less familiar with. It makes sense when you see it in expanded form. If you have the same amount on top and bottom, a squared divided by a squared, most of us are like, oh yeah, that's just 1. But if we think of that as a to the 2 as a to the 2 minus 2, or a to the 0. 2 minus 2 is 0. Anything to the 0 power is 1, and this is why. Because they cross out. Everything crosses out. You just get 1. And then lastly, the power of a quotient. It's kind of like this one, but where you have, kind of like the power of a product, but where you have 7 over y times 7 over y times 7 over y. So that's 7 cubed over y cubed. And if you wanted to, you could actually figure out what 7 cubed is. But the 7 over y cubed, the cubed goes to both parts. And that is the rule, the definition. And so that's what I wanted to do there. So let's look at some basic ones. So x to the 5th, x to the 7th. 5x's and 7x's make x to the 5 plus 7, or x to the 12th. Power to a power, so a to the 6th times a to the 6th times a to the 6th. So multiply. 3 sixes, so a to the 18th. And then 4 cubed times x cubed, or if you want 64. 4 times 4 is 16 times 4 is 64. No, wait, that's not right. Yeah. So 64x cubed. We get x to the 3 minus 5, which is x to the negative second, which is brought to the bottom. We never want to leave any negative exponents. I will try to always put this here, but know that simplified is with no negative exponents. A squared over a squared, 1. N to the 10th over n to the 4th. So subtract n to the 6th. Distribute your squared top and bottom, so you get x squared over 5 squared, or x squared over 25. Anything to the 0 power, 1. Anything divided by itself, 1. It means the same thing. 1 over x cubed. Anytime you have a negative power, bring it to the bottom. And by the way, up here, most of you could just go straight from here to here, and that wouldn't be a problem either. Let's try some more complicated ones. So we have 5, negative 8, and 6. So if you want to think of the negative 8 comes to the bottom, or you could just think w, and we add all the powers. 5 plus a negative 8 plus a 6. So 5 and 6 make 11, minus 8 make 3. So distribute this negative 2 to both, and what we do is we multiply the powers. So you have c to the negative second and d to the positive negative 4 times negative 2 is positive 8. And so now what I'm going to do is I'm going to bring the c to the bottom, and I'm going to write c2, c squared, and d to the 8th. And you could write the c first, you could write the d first, it doesn't matter. Alright, 2 things you can do. I'm going to take the negative 3 down to the bottom first. B squared, I'm going to write a to the positive 3rd power times a to the 5th. And then we're going to have b squared over, and then 3 a's and 5 a's make 8 a's total. Alright, this next one. I'm going to simplify the inside first, and then take care of the cubed. You could also take care of the cubed first, but there's just less multiplying to do if you simplify the inside. So looking at the a's, a squared and a cubed. And looking at the b, I'm going to bring the b down. So a squared over 2a cubed, b squared, b to the positive 1. And now there's 2 a's up top, 3 a's on the bottom, and so there's going to be 1 left over on the bottom, because 2 minus 3 is negative 1, or 1 on the bottom. And then we have 3 b's. And then we cube it. So we have 1 over 2 cubed, a cubed, and 3 times 3, which is 9. 1 over 8, a cubed, b to the 9th. And that's it. Alright, so finally, the last problem. Volume of concrete that was used to construct Hoover Dam is about 3,325,000 cubic yards. 1 cubic yard weighs 4,050 pounds. How many pounds of concrete were used to construct the Hoover Dam? So, cubic yards. If we multiply this by 4,050, pounds, lbs for some odd reason, right? Pounds per cubic yard. And you've done something like this where the cubic yard and cubic yard cancel out and you're left with pounds. And so here's what I'm looking at. The 325, 1, 2, 3 zeros times 4,050. So this is really what I want us to get at. What does 1.347 E negative 10, E positive 10, sorry, stands for 1.347 times 10 to the 10th power. This 10 will always be there. This 10 is right there. Just scientific notation. And I want you to be able to read it on your calculator. And that's the whole reason we're doing that. Exponent rules, congratulations. Make sure you remember them. Keep them straight. If you need to, write it out longhand and remember why it is the way it is.